Everyone knows that one-star reviews are detrimental to the health of your app, right? If you have an app that crashes a lot, it is basically an invitation for the user to rate it poorly and uninstall it. We ran some statistics on Play Store ratings, and it turns out that when leaving a one-star review, 50% of the time the user mentions the stability of the app. So basically, if your app crashes a lot, you have a very high chance of getting a one-star review. Now, the best way to deal with this is to prevent it in the first place, right? You just want to get rid of the bugs before they reach your users. So prevention is the key here. As you know, you can get bug reports from the Play Store after your app is launched, but you want to get them before your app is launched. That'd be far better. The problem is that you might have a device for testing, maybe a couple devices, maybe 5 if you're lucky. But the fact of the matter is that there are hundreds, thousands of different Android devices out there. Let's be honest, you cannot own all of them, right? You can't even own a majority of them. It's kind of a problem. So there's all kinds of different screen sizes, densities, orientation, like your app is probably doing different things in landscape and portrait. So how do you do testing across the board for this? Firebase has a solution called Firebase Test Lab for Android. And we do have to note, this is for Android. There's currently no iOS version, so good thing is here, I think everyone here does Android, right? Yeah, because this is an Android conference. So yeah, I wouldn't show you Firebase Test Lab for iOS. That would be silly. But with Firebase Test Lab for Android, when you run tests, and I'll talk about the different kinds of tests you can run, but what you'll get out of it is the logcat from your test run. So if there's a crash in there, you'll get the stack trace. You'll get videos, so you'll actually see, you can push a play button and watch your app run, or watch it play. You'll get screenshots at various points. So there's a screenshot API which you can use to capture screenshots, and if you're doing an automated test, which I'll talk about later, it will capture screenshots for you. And the newest feature is that you can get some performance metrics. So you can know throughout the time your app is running, how's it doing on CPU usage, how's it doing on memory, and also network egress and ingress. So as your app is doing these things, it's actually charting and graphing for you. So when the test completes, you'll have all these things. Now, probably, who here does instrumentation testing? Anyone? Okay, good, because usually there's not so many people, but now there's more people who are doing instrumentation testing. For those of you who haven't done instrumentation tests, these are specific to Android. So I'm a longtime Java developer. I've done JUnit, I've used mocking. And, instrumentation tests are different than that. Instrumentation tests are what you do in Android to test like activities, services, broadcast receivers. You're testing Android components here. They let you focus on the story for the user. So what you're doing is you're testing your app as it's being used by the user. So if your use case is click a button, see a screen, you code that. You click a button, and you test to see if the screen shows the way you want, which is a little different than unit tests, right? Unit tests don't typically deal with UI. They typically deal with business logic or things that are just like algorithm. You write your instrumentation tests in something called Espresso. That's the most common. We also support UI Automator. Previously, we supported Robotium, but we don't anymore. So just know that if you're somehow a Robotium user, we've dropped support for that lately. And what it does is it effectively adds extensions to JUnit. So if you know JUnit, if you're already doing unit testing with JUnit, the Android testing support library basically gives you a bunch of annotations you can use to mark what your tests are, mark what you're testing. So it should be fairly familiar. And if you haven't used the Android testing support library yet, please go do that. I think they just released version 3.0.1, and it contains some rather significant performance and usability benefits. And there's a code lab as well. So if you're new to Android testing at all, I recommend doing the code lab. It'll walk you through the creation of an app and unit tests for it. Now, does this look familiar to anyone? To people who do instrumentation testing, this should look fairly familiar. For those of you who haven't done instrumentation testing, notice that there's special annotations here. There's a run with annotation, which says, I'm doing an Android JUnit test right now. There's a rule that indicates which activity in my app that I'm testing. And then the test annotation, that's your standard JUnit test instrumentation saying, this is a unit, or this is a method I want you to run. Now, you'll notice there's a couple on views and with IDs and some special looking stuff here. That's Espresso language for saying what you want the app to do. So what this is saying is when a view becomes visible and when the view with an ID of fab_add_notes, click it. So when that button is visible, click it. Then wait for something else to show up and check to see if it matches the text that you expect. So this is what we'd call like a fluent language for doing instrumentation testing. Now, like I said, I'm a longtime Java developer, so I do also regular unit testing. And you typically run these locally, so you run them on your machine, not on an Android device. They run faster on your computer. You should get fairly instant results. They focus on algorithms, methods, objects. Do they function the way that you want them to? You can also do things like dependency injection. So if you have objects that depend on other objects, you don't want to test all the objects at the same time. You want to test one object at a time. So you use dependency injection to insert objects into, or as dependencies into your testing objects. This is the preferred way to do it. So anyway, if you've done unit testing, this is all pretty straightforward. Now, if you're working in Android Studio, you have, under the Android test folder, you have your instrumentation test, and under the test folder, you have local unit tests. And like I said, local unit tests typically run on your computer. Instrumentation tests run on a device. The thing is, I don't like to run them separately. I want to run them all together, and I want to run them all together on as many devices as possible. So there's a little pro tip here. You can run them all together as part of instrumentation test by just adding the test directory to your list of source directories that Android is going to look at to find instrumentation tests. The thing is, if you're using something like Makito for dependency injection, you're going to need to add this extra dependency. So Makito does some black magic to get to actually mock objects. Well, in Android, it works a little bit differently than it does in Java, so you need to add an extra dependency to make that happen. Does
that make the unit test run on the device?
Yes. You're effectively saying all of my unit tests and all of my Android instrumentation tests all run together in one big batch. So you don't have to do them separately, and you can run them across all the different devices in TestLab. And I didn't mention before, TestLab, there are like thousands of devices in this lab, and there are, I can't remember how many different device types. So you're selecting from things like Galaxy devices, Nexus devices, all HTC devices. There's a ton there, and you can run on as many as you want, as long as you're willing to pay for that time. There's also virtual devices. So virtual devices, the good thing about virtual devices is that they have versions of Android available before they've been fully released. So if you don't have the latest Oreo device, you can always depend on TestLab to provide virtual devices for the versions of Android you don't have yet. Now, I don't know does anyone here use strict mode during Android development? Strict mode. Okay, a couple strict mode users. I found out that and I like strict mode, by the way. I always have it on during development. In fact, I have it crash the app if I do something wrong. So strict mode will check for things like best practices. So if you're doing I/O on the main thread, that's a no-no. You want to know if you're doing that. You want to know as early as possible if you're violating any of these best practices. So strict mode, you can turn them on, have it crash your app. Then when you run it in TestLab, you'll get a report on all these devices where you may have made a mistake. So what I like to do is when the app first starts, I'll enable strict mode. And first I'll check, should I enable strict mode? Now the question here is, at what point do we want it on and what point do we want it off? You don't want to ship an app with strict mode on, especially if it's going to crash your app if you made a mistake. You don't want a mistake, to cause problems for your users. So I'll talk about the decision, that decision. Next line, I'm using strict mode, and there's two different kinds of strict modes. There's one for thread policy, meaning for the threads in my app, what rules do they need to obey? The VM policy is similar, but for the entire VM, what kind of rules do they need to obey? So what I do is I enable both of those. Only if strict mode should be enabled. Now, typically, you decide if you want to enable strict mode by saying, is this a debug build? If it's a debug build, you probably build it on your desktop, and you probably are testing it on a local device. But if you want to enable strict mode in TestLab for a release build, you can ask the device, are you a TestLab device? You can write this little bit of code that says, if I'm either running in debug mode or I'm running in TestLab, go ahead and turn strict mode on. So now you can have a release build running in TestLab that will crash if you make a mistake. Now, there's another, I won't spend too much time on this, but there's another thing to be aware of, is that certain versions of Android actually, if you enable debug mode early on, then launch the app, or then the app goes through its launch, Android will do the privilege of disabling strict mode. You have to turn it back on. So I would just read the URL up there to find out what that's all about and how that's been fixed. But you should know that, because if you think you're enabling strict mode and it's not actually on, you'll be kind of disappointed, or think that you have very good coding practices, but not actually. Now, you might be thinking, I can do all these tests, I can learn Espresso, I can write all this code, but let's face it, who here really enjoys testing? Really enjoy? Okay, so there's one, okay, two. I always ask this question, nobody really likes to do testing, right? But everyone knows their app has to be tested. So If you don't want to write tests, that's okay. You don't have to learn how to write unit tests in order to get testing. So in Android Studio, if you haven't seen this yet, it's kind of cool. There's an Espresso test recorder. And what it does is it'll launch your app in a special mode where it records what you're doing and then creates Espresso tests from that. So you launch your app, push some buttons, it knows all those button pushes, translates that into Espresso code, then you can run that in Test Lab or locally. So it looks kind of like this. So on the right, there's an emulator window, and on the left is the Espresso test recorder window. And you'll notice that it's logging a bunch of things that it's doing, and we'll take a closer look at that. So it knows that you tapped a button, it knows that I added a new note, and there's some text in it, and that's the use case. So again, the result of this is a Java file with Espresso code that has test code ready to run. Now, you might be thinking, this is actually also kind of a pain, right? If you don't want to actually run through all of the different use cases in your app, you just don't even want to have tests. That's okay. We can still test your app, even if you don't want to have tests. So in Test Lab, there's this thing called a robo-test. And a robo-test is a fully automated, intelligent testing system that will systematically crawl your app in the same way that Google might crawl your website. And it will push buttons and find menu items and generally try to get through your app as much as possible looking for crashes. So a robo-test only requires an APK. So if you're in the Firebase console, if you're using the command line, all you do is ship it an APK. And it could be a debug APK, it could be a release APK, it doesn't matter. All it has to have is a launcher activity. And it will automatically log in with Google Auth. So if you're using Firebase authentication and have Google authentication as a login option, it will actually log in with that. It has its own account, so it knows how to get into your app. It can also pre-fill form fields. So if you have like a username password login, or if you have a search bar or something in your app that requires text, that would normally block an automated agent because it doesn't know what to put there. But with Robo, you can tell it for a text or for an edit text with a certain ID, put text there. Or when a button is seen, click the button. Like you're directing it at certain points so it can get through some parts of your app. Robo also has a sense of maximum crawl depth, so it will think of the first activity as the root activity, and then it will crawl. You can also limit the depth. This is important if your app effectively has rabbit holes that you can't get out of. You can say, well, maybe the maximum depth is 5. Once it climbs down that rabbit hole, it can get back up, and that should increase the breadth of the test of your app. And the algorithm does improve over time. And again, RoboTest is smart. So if you know Monkey Runner, if anyone's ever heard of Monkey Runner, that's a dumb test. And not to say that Monkey Runner is dumb, it just doesn't have any brains behind it. It doesn't know what it's doing. It's just sort of randomly generating events. Robo is smart. It's algorithmic. It's predictable. And the algorithm improves over time. In fact, I think just a few weeks ago, the Test Lab team released a new version of Robo that's faster, crawls deeper, generally finds more positive, like actual crashes than the prior version. And there's one additional test artifact. So if you run a robo test, you'll get an activity map. So I mentioned there's the root activity and all the other activities that it found. You can actually see how it traversed your app, which is very helpful to understand what use cases it's actually testing. Now, this is great for apps, right? So apps have nice widgets and buttons and are generally easy to crawl. If you are building a game, and is anyone here a game developer? No game developers. But if you were building a game, so the funny thing about games, right, they tend to take over the screen. You know, they don't have like standard UI widgets. Robo doesn't know what to do with the game. It just sees a big screen. It's like, I don't know, there's no buttons, there's no widgets, I don't know what to do here. But if you do want to test your game, you could think of like arcade games. Arcade games play themselves, right? There's a demo mode and a tracked mode. If you're a game developer, all you have to do is build these sort of like demo mode, and then Test Lab can test it. So there's something called the game loop test, which is currently in beta. Basically, you create a series of scenarios, and those scenarios will be invoked by intents. So in your manifest, you say how many different scenarios you're advertising to the system. The system will systematically invoke them and run through them. If you do a game loop test, you'll also get an additional performance log for frames per second, which is, of course, big for games, right? Games want to be running at a nice, smooth 60 frames per second. And it's not even just games. Actually, anything that uses surface view, I believe. So an Android surface view is something you use to draw directly in when you take over the screen. So any app using a surface view will get FPS included in the performance tab. And there's a code lab for this as well. So if you need help getting started, and none of you are game developers, so I'm just going to skip this anyway. If you want to try this out yourself, there's actually a Mecha Hamster sample game. This is fully open source. This is a game that the Firebase team put together to illustrate how Firebase can be used in games, so Firebase actually, you can use it in Unity, in C#. The Code Lab will go over how to add the game loops, but if you want to just look at the code for the game itself, it's available here. And a game loop looks kind of like this, where the game is basically just playing itself. So you can see it's just running through a particular scenario. And then after this runs, what you'll get in the dashboard is this is a view of the performance tab. So you can see how memory changes over time, graphics, and CPU are changing over time. I don't know if you can see this, but there's a little like gray line right here. That's actually a scrub bar. You can scrub that wherever you want, and it will show you the point in the game where it's running. So now you can look at performance-related events and find out what was going on exactly in the game at that time. So it's very helpful if you want to know why there was a dip in FPS anywhere. You can actually see the point in the game and make a sort of more informed decision about what was going on and how to fix it. Now there's 3 different kinds of tests you can run in Test Lab. I mentioned game loops, I mentioned instrumentation test, and I mentioned robo test. So if you're using the console to run the game, you just choose the type of test and upload your APK that way. You can also run within Android Studio. So if you know everyone knows run configurations, right? When you launch your app, you push that little green button, and there's a run configuration behind that that basically says, how do I launch the app? Well, you can create a run configuration for Test Lab. So you can basically use that little green button to launch tests in Test Lab through Android Studio. So that can be a pretty convenient way of doing tests. And another way of running tests is through the command line. So there's a G-Cloud command line. If you're wondering what G-Cloud is basically the command line that all of Google Cloud products use. And Firebase is it's like built on top of Google Cloud, so we make use of the G-Cloud command line. Now, you probably don't want to type this every time, right? This is a fairly intimidating command line. There's a lot going on up there, and it can get even more complicated as you have more devices and more configurations to add to it. So I would recommend for day-to-day development, you probably don't want to work with the command line, but the command line is very important if you're doing CI integration. So does anyone use CI tools? Okay, good. So if you're building your app on a CI server, you definitely want to use the command line to kick off tests at the end. So in theory, every time your CI server builds, maybe every night, maybe with every commit, you could run a series of tests and have that potentially fail the build if there's a test that's failing. Now, we have a pretty robust community of people who are working with Firebase Test Lab in their CI environment. So Walmart, one of our biggest customers, has Flank, and that will help you shard your tests so you can run them concurrently on as many devices as possible. So this should, if you have a lot of tests, you know they can take hours to run. So this should cut down the time it takes. We have Circle CI integration, and we have Buddy Build integration. Did anyone hear from Buddy Build? Anyone? Okay, we have Buddy Build. So if you have questions about Buddy Build and maybe Test Lab, ask this fellow right here. All right, and there's one final way to run a test, and you're not doing it directly, you're doing it indirectly. So this is the Play Store console. There's something called a pre-launch report. Your pre-launch report contains a bunch of diagnostics and statistics about your app. If you opt into this, you will get a free 5-minute robo test as part of uploading your APK to an alpha or beta channel. So if you're not using alpha or beta channels, use them if for no other reason to get a free test out of it. And there is a free tier for Firebase Test Lab in general. So you have a limit of 10 tests per day on virtual devices and 5 tests per day on physical devices, which is, if you just do nightly testing, that's probably more than enough. But when you start to do really serious testing, like some of our biggest customers are running hundreds or maybe even thousands of tests per day, and you're paying basically per hour at this point. We think the prices are pretty reasonable. So say you've tested your app, you're fairly confident that it's ready to publish, you're feeling good about it, but there's always that anxiety of publishing the final app, right? I don't know about you, but every time I send that APK to the Play Store and I'm like, is this the right one? Is this going to work? Are there any crashes? I don't know about you, but I always miss something. Like no matter how well I've tested my app, something always falls through the cracks. So when it comes time to publish, you probably need something to tell you if there's an actual error in the wild. So you need some sort of bug reporting tool. So Firebase actually has 2 right now. There's Firebase Crash Reporting, and as you know, Firebase joined forces with Crashlytics, well, Fabric, which has Crashlytics. We have 2 crash reporting tools. Now, you might be wondering, why do you need 2 crash reporting tools? Well, the fact of the matter is, Firebase Crash Reporting does some things that Crashlytics doesn't do, and Crashlytics does some things that Firebase crash reporting doesn't do, but Crashlytics is now the primary crash reporting tool for Firebase. So we announced this actually a few days ago at the Firebase Summit in Amsterdam. Crashlytics has Unity support. If you're working with the Android NDK, there's NDK support. You can search issues. There's webhooks. So if there's a crash, you can receive a webhook trigger. And now there's Cloud Functions integration. So this is actually very new as well. So with Cloud Functions, you can write backend code through a sort of serverless environment. So you can basically write Node.js code that will get triggered every time the system sees a new crash. Now, the one thing that Firebase Crash Reporting does better than Crashlytics is it has integration with Firebase Analytics. So it will generate events with each crash. So now that event becomes part of the user's event trail. So now you can know or create an audience of people who have had crashes. And similarly, when there's a crash in the log, it will have all of the analytics events that they generated. So this helps you sort of figure out what the user was doing up until the time of a crash. Now, eventually, I would like to see that Firebase Crash Reporting gets this its integration with analytics would go into Crashlytics. That's my hope. I'm trying very hard to get the team to do that. I think that would make it a very robust feature. Now, it turns out on Android, you can have two crash reporting tools side by side. On iOS, you can't because of the way signal handlers work. But on Android, you can have two, you can have three, you can have any number of crash reporting tools. And if you want to capture crashes on your own, all you have to do is create an uncaught exception handler. An uncaught exception handler basically is a bit of code that gets invoked when there's an exception that was not caught anywhere along the way, or a crash. This is what would crash your app. So if you want to create your own uncaught exception handler, all you do is subclass it and do the right thing in there. So this illustrates what the right thing is. And the right thing for any uncaught exception handler is to call through to the prior exception handler. So you can see here, this one is taking an uncaught exception handler in its constructor, remembering it, and then calling through to it after it's done handling. Now, interesting fact, if you don't do this, there are problems, and I'll illustrate what that is later. But to set up your uncaught exception handler, you get the default. So you use this API, thread.get default uncaught exception handler, which is a lot of words, verbose Java, right? Then you set yours in its place. And because yours is taking the other one as the prior, it will call through. So basically, each uncaught exception handler is calling each other in a chain until you get back to the original uncaught exception handler that Android provides. And it does things like this. So it looks different in Oreo now, but probably everyone has seen this screen, right? I mean, you know, you've written an app that crashes. Everyone's written an app that crashes. Actually, I kind of like this dialogue because it says, you know, unfortunately something bad happened, and my only choice is to be okay with it. This is wrong, right? So I think the Oreo dialogue is a lot better, but yeah, I'm never okay with the crash. Anyway, this is what the original default uncaught exception handler does in Android. It does this. Now, it turns out if you have an uncaught exception handler and you don't call through to the prior, this screen will not show up. If you're not calling into the prior, the app will not crash. And you think, that's great, my app will not crash. But you could be in like a terrible situation. You could be like out of memory or in some bad state. So always call through if you're capturing your own crashes. OK. The other thing that is that you can use to help boost the quality of your app is not just testing, not just crash reporting, but also good performance. So a high-quality app is performant. And it turns out if we analyze 5-star ratings on the market, 60% of them mention the speed, design, or usability of the app. So speed is the thing that I'm concerned about. I can't help you too much with design or usability. Firebase is not a design tool. It's an implementation tool. But we'll look at tools for helping speed. So who here already knows systrace? Anyone here use systrace? OK, a few hands. So you know systrace has a very detailed view of what's going on in your app. So you can see here it has some records of what's going on in the different CPUs, what's going on in different threads. You can really dig down deep to know what's happening moment to moment, minute to minute, you know, millisecond to millisecond, what's going on in your app. It's a very handy tool. It is very detailed. You can do custom traces in there. However, your app will run slow. So if you know, systrace users know when you're running your app, or systrace against your app will slow to a crawl, and slow to a crawl. You also have to know what you're looking for. So you can't just have systrace running in your app all the time. That's not the way that it works. You have to know there's a performance problem and then dig down into the details for that performance problem. It can only collect data from connected devices. So as users are using your app, there's no way to have systrace weasel its way into the app that's running in production. So how do you get performance data from your app running in production? Well, that's what Firebase Performance Monitoring is for. Firebase Performance Monitoring runs in production in the app running on your user's phone. So it's collecting the actual performance of users or your app as your users are using it. It has negligible overhead, so no one should be perceiving that this data is being collected, unlike systrace, where it's very noticeable. You can do automatic traces, and I'll talk a little bit about what those are, and you can do custom traces. You can say what parts of your code you want to measure and get telemetry from that. And it will also automatically measure your HTTP traffic, and I'll talk more about that later. So the basic unit of understanding that performance monitoring will give you is called a trace, and a trace is essentially a report of some amount of time that has a distinct beginning and end. There is no trace that has no end. Every trace has a beginning and an end, which means it nominally has a duration. Every trace has a duration. If nothing else, a trace, you know how long it takes. Now, we can attach more data called counters. So inside a trace, you can have counters, and those counters are basically counting performance-related events during that trace. And I'll talk a little bit about that in a bit. So with automatic traces, you don't write any code. Integrating the SDK without writing any lines of code, you will actually get app start, a cold start. So cold start for an Android app is when the user launches the app, the process has not already been started and cached by Android, so that's the cold start. It does not measure when the user leaves your app and then comes back in when the process is already running. It's only for that first cold start. And it'll measure things like time in the foreground and time in the background. So these are a couple of automatic traces. The team would like in the future to have even more automatic traces. And again, performance monitoring is in beta, so just bear that in mind. We haven't had anyone complaining that it doesn't work the way that it's supposed to, but we think it's incomplete, and so you can expect more stuff in the future. So with app start, how does it measure what a cold start is? We define cold start as a content provider on create. So performance monitoring will inject a content provider. And for those of you who don't know what a content provider is, it's basically a way that apps use to share data with each other. But we're kind of using it here because they get initialized early, like first thing in your app. So this is how we know when your app is launched. This first thing, this content provider on create, measures the beginning of a trace. And it will go until the first activities on resume is called. And that's when we say the app is basically responsive. It accepts touches. You should see something on the screen. So this is cold start. And this is automatic. But practically speaking, you might want something different than this. So we've had customers who say app start time for me is from the moment the user launches the app to when the home screen is fully filled with images and data. So you may be depending on some network traffic there. And you want to measure that as well. That's part of the overall app launch experience. So if you do this, you can create your own trace and measure that instead. Now, when you have a trace and you want to add more information to it, like the duration just isn't enough, you want to know what happened during that time, you can create a counter. I always recommend for you to think about what's actionable to add. So I have some examples. So say if you have an image caching solution and you want to know every time there's a hit or a miss, you can add a counter for that. Maybe you have a way of measuring drop frames, so you can increment a value in there. So at the end of this trace now contains a bunch of counters. Those counters get aggregated and put into a dashboard for you to see how this trace is actually performing. Is it good? Is it bad? Is it within the speed that you want? What's the histogram look like? So how many users are actually very good versus very bad in their overall experience? I missed this. So with counters, you're essentially associating a string count value to a trace. And like I said, it's typically better to do actionable things. And I recommend measuring ratios. So like cache hit to miss ratio, I think is a very good example. Let's see, I'm going to jump ahead to pseudo-automatic traces. So I actually wrote a blog post about this a couple months ago. It can be kind of a pain to write all these traces, right? You're writing a little bit of code to invoke this trace, start it, and stop at the right point. I think it would be great if, say, every activity in my app was fully instrumented without writing lines of code in every activity. So I have an idea for something that you could implement. It uses application lifecycle callbacks. So does anyone use that? Okay, wow, that's great. So these are really handy. What they do is they automatically let you listen into the activity lifecycle for all of the activities in your app. So on create, on start, on resume, on pause, and so on and so forth. There's callbacks for that. So there's an interface you can implement, activity lifecycle callbacks. And what I'm going to do here is create a singleton pattern. And within that, for every activity that gets started and for every activity that gets stopped, I'm going to start a new trace. I'm going to get its name, and I'm going to store it in a map. And that map is sort of holding on to all the activities that are currently started. So when an activity started, it gets put in the map. When the activity is stopped, we take the trace out of that and stop it. So now this will automatically cover all of the activities in your app. Now you have a trace for all of them, and you're only writing this little bit of code. And you can also expose another method on this. So if you want to get a hold of the trace that's currently running for an activity, you can use this method to reach into that map, get the current trace for the activity, and then add counters to it or whatever you want to do in that trace. Now you want to initialize this somewhere. So activity lifecycle callbacks, they need to be added at some point. And again, I'm going to use a content provider here. Content providers, again, get initialized very early within the application lifecycle. So you can be confident here that if you add the lifecycle callbacks during content provider, it will be active for every activity that's in your app. It will always get called before any activity. And then inside your activity, if you want to make use of it, just reach into the singleton instance, grab the trace, and do whatever you want with it. Now, you might be looking for ideas for other things to add. So, timing things is great, but, what if you don't even have a sense of what could be a problem in your app? Because you kind of have to know ahead of time, right? You can't just be told, here's all of your performance problems, fix them. Maybe you just have to have an idea. So I suggest you look at Android Vitals, and this is a relatively new thing in the Play console. It will show you performance-related stats for your app. So slow rendering, which is also known as jank, and I believe this is going to be measured in frames per second. There's also a concept of frozen frames. And a frozen frame is defined as any frame that takes more than 700 milliseconds to render. So it will tell you where that's happening. And also, it will measure stuck wake locks. So if you've ever worked with wake locks, it's a way of keeping the device screen on or something awake in the device longer than the user might want to, and that's okay. But if you start a wake lock and you don't stop it, that's a performance problem. That's potentially a battery-sucking performance problem, so you need to know about those as well. Now, what do we collect automatically for HTTP transactions? Well, performance monitoring will give you the response time, so that's the duration between the start of an HTTP transaction and its full response. There's the payload size, so how many bytes did it transfer, and the success rate. And this is just the HTTP code. So like 200 error or success and 500 are errors, as you know, in HTTP. So you'll be told which of your API calls are working and which ones may be not working as well as you'd like. And of course, you're probably accessing a ton of URLs in your app, right? And you probably may be calling a REST API. So you'll need to know how each one of those are working with respect to each other. So it will automatically do URL pattern globbing. So here, maybe you're pulling images from a CDN. You can see there's a little star there. It's actually saying, for all of the images, here's how they work in aggregate. Or if you have a REST-style API, it will glob those as well, because you don't want to measure every single user history access, right? You want to measure all of them together, because they're all the sort of same, they should all have similar performance characteristics. And you can break this down even further. So once you have all of your patterns globbed and you have all your data, you can break this down by app version, device country, OS level, carrier, and radio. And this is important because your API calls are obviously going to be faster on Wi-Fi than they would be on a 3G connection, right? So you need a way to break these down and figure out if there is a performance problem, what is the actual cause? Or how many users are experiencing that? What is the property of the device, right? Because very high-end devices with good Wi-Fi connections are very different than low-end devices with terrible connections. You need to be able to separate those so you can figure out better what is the exact nature of your performance problem. Now, you might be wondering, how does this work? Like, what kind of crazy stuff is going on in there that lets an SDK that's built into your app automatically measure HTTP transactions? It seems like kind of a weird thing, right? So it turns out it's on Android, we use bytecode manipulation. So there is a build phase when you use the Firebase Performance Monitoring SDK. What it will do is it look at every single class in your app, look to see if it's making an HTTP transaction, and wrap that into something. So it'll look for things like this. So here's a standard HTTP URL connection, standard Java, right? What we're doing is we're finding a URL, opening the connection on the URL, and casting it to an HTTPS URL connection. This is a sure sign that this is about to do an HTTP transaction. So at build time, what we do is we take that and we rewrite it to Firebase perf URL connection.instrument. You can see that URL open connection is still there, but we've just decorated it within something else. So this is still an HTTPS URL connection that looks and behaves just like the one that was originally created, but now it's been instrumented. So the methods you call on it, we're sort of like listening in and figuring out, when did you start the request? When is it over? What was the number of bytes? This is how we sort of gather all that information. Let's see how this actually works in practice. You pull in the SDK. So this is the runtime component, but you also need to apply a plugin. So this is the plugin that does the bytecode manipulation. So if you're wondering how that works, this is how it works. And internally, it uses something called the Transform API. So this is a way that you can integrate into the Gradle build using the Android plugin. What that does is it exposes this thing called a Transform API that lets you listen in on everything that's going on. So it'll get past every jar file and every class file. And it will have an opportunity to rewrite that if it needs to. This is actually how ProGuard works, right? So ProGuard is listening in on all the jar files and all the classes. It's figuring out what's used, what's not used, how to compress things. So anyway, Firebase Performance Monitoring is using the Transform API. Okay. So the last thing I want to talk about is remote config. So remote config isn't normally thought of as a app quality tool. Usually you think of this as a way to sort of alter the behavior and look of your app dynamically without having to republish a new version of your app. So yeah, that's basically what it does. So you can put hard-coded constants in there. You can put localized strings in there. There's a lot of things you can do, but what I want to focus on today is the ability to use it to plan and stage rollouts of new features in your app and quickly back it off if there's a problem. So you probably know, well, those of you who do iOS know that there could be a lengthy waiting period before your app actually makes it to your users. Same thing with the Play Store. You don't really know from the moment you hit publish when that will actually be available to your users. And you don't know when your users are actually going to download it. So if you want to do a fast release of a feature, it's often not that fast, right? You end up having to wait this unknown amount of time. So what you can do with remote config is code any new features behind a remote config parameter. So it's just a simple Boolean. Do I show this feature or not? And you flip the switch on the console so that your users see it basically all at the same time without having to wait for publication. So if you want to test a new feature, you can define a new, this is the remote config console in the Firebase console. You can define a new parameter, I'm going to call it using cool new feature, and the default value will be false. What I'm going to do is click that button, add value for condition. So we can define a new condition. We can say it's just another simple Boolean. Is this cool new feature active? And this is interesting. So I'm defining, there's a lot of things, a lot of conditions you can add, but I'm using a random percentile here. So what this is saying is the bottom 10% of all of my users are going to see this true, and the other are going to see it false. So now what you can do is slowly roll out this feature to segments of your users. And if there's a problem, you just turn it off, right? That's always the big thing, right? If you want to ship something new and if you're not confident it's going to work, you might want to just turn it off, right? It's easier than building and publishing a whole new app. So what I'm going to do is add this, so the default value will be false, and if the condition is true, then using cool new feature is true. And when it's all set up in the dashboard, it'll look like this. So you can see very clearly what's going on here. Now, in your app, what you'll want to do is use the Firebase Remote Config API to just query that Boolean. Am I using this cool new feature? If so, use it. If not, not. It couldn't be any easier than this. Now, Firebase Remote Config, in a very general sense, allows you to do experimentation. And for those of you who've been following Firebase, in Amsterdam just a few days ago, we announced Firebase A/B testing. So that's a more formalized way of doing A/B testing so you can find out what works better for your users, what makes you more money, what makes your app more effective. You can study the results in analytics. So A/B testing is great, but I have a creative use for it. You could use it for A/B testing your performance. So imagine you have a bunch of images in your app and you want to distribute them through a CDN, and you might be trying to figure out which CDN is the best one, which is best. And you want your images to be as fast as possible. How do you measure it? So the idea is maybe you use 2 CDNs and you A/B test them. You measure their performance. This seems to be a great way to find out what's better for your users in terms of performance. The other thing you might be wondering is, like, how big should I make an image cache, right? How do I configure that? What's the optimal size for that? And again, you could use remote config to remotely configure the size of your cache and do an A/B test to say, well, is 20% of memory or 30% of memory better? I don't know. Let's just test it and find out. So again, you can use the Firebase Remote Config API and set up a parameter. I'm just calling this one cache size. It's rather arbitrary. So what I do is I create a trace, I reach into the cache to get some resource, and increment a counter. Now notice here I've got 2 different counters. I've got one for cache hit size and this cache size parameter, and one for cache miss size, and again that cache size parameter. So if I'm doing an A/B test between 20% and 30%, I now have two counters in here that are measuring what my cache hit and miss ratio is for this trace, for this app, for the segments that you've defined. So I think this is pretty handy, right? Usually, like if you're testing performance, you have to do it on a device, in your hand, and measure it, and use systrace, and that's kind of, that only tells you the performance of your app in your hand at the time that you run the test. What you really want is to study it for all of your users. So I think Firebase performance monitoring and remote config work really well together for that kind of use. If you want to learn more about Firebase, you can go to our homepage. There's a Slack channel where a lot of engaged users and staff hang out. We have YouTube channel where I do a lot of videos on YouTube, particularly Android videos. I'm very active on the blog. We have a lot of blogs going through. There's going to be some product announcements that are coming out of Amsterdam from the Firebase Summit. We also tweet a lot as well. So be sure to follow us on all of these channels. And thank you for your time. Does anyone have any questions about anything I talked about?
Can custom ROMs be loaded on Firebase? And next question is like, if yes, can VPN services be connected using virtual devices on Firebase?
Right, so there are no custom ROMs. In fact, we use only stock ROMs, and they've been modified in such a way to work with test labs. So it's not terribly feasible to have like custom ROMs because they wouldn't be instrumented the way we expect.
We work on custom ROMs, on developing custom ROMs, and I was just thinking maybe if that custom ROM can be loaded somewhere so that we could test that on virtual devices on Firebase.
Oh, no, we can't do that either, sorry. Yeah.
Yeah. So you said that instrumentation test, if you have Google, it will log in automatically. What if you don't have Google, but you're still using OAuth best practices where your login screen opens on a custom tab? Mm-hmm. What have you seen that people are doing, or is there a way that, how do you go about doing that?
Well, the reason why Google Auth works the way it does is because we can recognize that the dialog is appearing, and we know exactly what to look for, right? We control it. If you're using Facebook, it's different because they open up a web view, and we can't really work with that web view very well. But if you don't use Google Auth and you're using like password-based, like username password, you can just fill in those fields yourself, right? So you can just write the espresso to enter the username or password, or let Robo like tell it, where to enter those values. So we find that a lot of people use email login, and that's the best solution for them. So.
Okay. But nothing for if you're using custom tab and open the login on a.
Well, I'm not sure what you mean by custom tab, because these are Android native.
Basically, we kick the login to a browser, and then we use a URI redirect back into the app once you're logged in.
I see. Yeah, WebView is tricky, right? When you write Espresso, well, I think there's a new Espresso library for dealing with web UIs. I mean, that would be probably something to look into if you wanted to script it yourself. We can't do anything automatically with that, though. Yep.
Thanks for the talk. It's very powerful.
Thank you.
Some of us Android developers also do iOS and React Native. Does this apply to the other two platforms as well?
Right, so as I said, Firebase Test Lab for Android is for Android only, unfortunately. The team would love to have other platforms in there. All we have time to invest in is Android at the moment, so please, if you do want it, file a feature request. And like everyone just becomes another voice saying, we want this and we want it badly. I don't know about React Native, though. That is a whole different thing. But definitely, if you want that, ask for it. For performance monitoring, that is Android and iOS. I mentioned the Android implementation uses bytecode manipulation. On iOS, it actually uses runtime method swizzling. So it measures all the same stuff, just in a completely different way. React Native, we don't have any performance stuff for web yet, but we know that that's going to be hotly requested. So again, file a feature request. It is a good voice to have. Thank you.
For Firebase performance, you showed an example where you show a map of activities and traces. Mm-hmm. What happens if you recreate the activities, like orientation change? Will you use the traces, or it's going to be?
Yeah. So so if there's a reorientation, the activity is going to be paused, stopped, destroyed and a new one created unless you've disabled that, unless you've said, I want to handle that myself. So if you handle it yourself, you won't run through the life cycle and you won't get a new trace. By default, though, you will get a new trace for each one of those. So if you need to preserve that trace across orientation changes, you'll need to use something like a loader or like a headless fragment or one of those ways of retaining state in a way that's like, where you could store arbitrary objects in there. So you have to do that yourself.
Can't you just use activity names, for example?
I'm sorry, say that again?
Instead of using the activity itself as a key for the map, can you use strings?
Strings?
Yeah, and that example, I mean.
Well, what would the string be? I mean, you could, but you'd have to find a way of uniquely identifying that activity with the string. You can't just use its name because there could be two of the same activity, and at that point you're colliding your traces. So if you have a way of coming up with a string, yeah, you could do that yourself. Mm-hmm. Yeah.
Hi. So you mentioned that you can run robot test as a pre-published step, yeah, for your APK. So does it mean that it's going to actually run it on production APK? Because, for example, if it runs a robot test, I really don't want it to hit my production service or just make some weird posts or whatever.
Yeah. So Firebase projects, we typically advise people to have one project for each different environment. So in development, everyone probably should have their own project, everyone on your team. In staging, you might have another different project that manages your staging data, and then another different one in production. So yeah, you could run Robo against all of them. You just have to choose which APK, that you want to run in the right circumstance. I mean, it's up to you to decide that. But if you're asking specifically about pre-launch report, right, so that one theoretically is the one that you want to go to your users. Now, I would think of Robo as your first beta user. That's how I think about it. So Robo is a user. The question is, are you comfortable having that user mess with your production data? And if you're not comfortable with that, then you should probably not use a pre-launch report and just test your staging app differently. So.
Is there any way to limit Robo to say don't go to activity A or B?
That's a good question. Is there any way to limit Robo? I don't think there is. Actually, we should talk about that because the team, I think, might want to know that. If you can sort of set up a gate for it to play within, that's a pretty good idea. Anyone else? All right, great. Well, if you want to talk to me or anyone else on the Firebase team, we have a table right out there. So please come and talk. We want to hear from you. Thank you.